Alrighty, today we're going to be working on solving linear one-variable inequalities. We started the day by looking at these math notes, talking about, well, when do we fill in the dot? When do we leave the dot empty? When do we travel up the number line? When do we travel down the number line? And hopefully you had a couple of these key phrases and ideas highlighted in your own math notes. The first one is that we had this first example of the x is greater than or equal to -1. We're going to use a filled in coordinate, or a filled in dot, if you will, a filled in point, which will indicate that it not only approaches the number -1, but it actually hits or touches or equals the -1. In this case, we have x is greater than or equal to -1. The greater than is because the alligator or crocodile or whatever it was that you were taught back in, the day, is eating the x, which means that x has to be bigger than the other thing that's on the other side. So therefore, we would travel up the number line because x is again greater than or bigger than the -1. Down here, we would use an empty or what's called an open coordinate. An open point that would indicate that that number, in this case it's -3, is not actually part of the solution. We have this open circle here, don't fill it in, and it's going to travel downward. Now the downward has nothing to do with the openness of the circle. The downward trajectory has to do with the fact that up here we have x is less than. The alligator is instead choosing the value of -3 to eat instead of the x. Whereas up here, again, the alligator was choosing to eat the x rather than the value. Now over here, you were supposed to have matched the 4 different phrases with the symbol that it represents. And I guess in this, I am assuming that you're assuming that the x is over here on the left side of the inequality. And that the number, whether it's 3, 10, a billion, -27, it doesn't matter. But the number and the value is over here on the right-hand side. For this first one, we would match up x is less than the value. There's no half of the equal sign underneath it, so we would match this with this phrase right here, less than. Underneath it, we do have half of the equal sign. So it's actually less than or equal to. Third down, we have x is greater than, because again, the alligator is choosing the x rather than the value on the other side. There is half of the equal sign, which is why we would match it up with the words greater than or equal to. And then, of course, by our powers of deduction and or knowing that this symbol, x, is greater than, no equal sign, the value, it would just be the term greater than. After that, we were supposed to have drawn these inequalities that were given to us on a number line itself. For the first one, we should have a filled in dot at the -2. Because you see over here you have half of the equal sign, so it should be a filled in dot. The reason it's traveling upward is because it's a greater than symbol. X is greater than the -2. You should always start your number lines at the value of 0, unless of course the number is so outrageously far away from the 0 that it's not really reasonable. But in this case, we would say, okay, for part B, we would say x is less than or equal to +1. So we start with that number right there, number 1. We draw our dot. We ask, is it open or closed? Filled in or empty? In this case, it's going to be filled in. Because again, the x could actually equal the 1. And then our third question is it going above? Is it greater than? Is the x greater than the number? Or is the x smaller, less than the number? In this case, we have x is less than the value of 1. So therefore, I'm going to color it in like this, make my arrow, and there we go. We continue doing the same thing for each problem. You probably got a little bit perplexed looking at part C because you were like, well, there's no inequality. Not a big deal. We still start at 0. 1, 2, and 3. X equals 3. X is 3. X wants to be the 3. It doesn't want to go anywhere else. It's not greater than it. It's not less than it. It's equivalent to it. So therefore, we just simply draw our dot, and that's that. The only other tricky one that might have given you a bit of a challenge was probably F and G. F down here not only has one inequality symbol, but rather it has 2. So this one is a little bit tricky in the sense that you have to figure out not only one dot, but 2 dots for this inequality. We're going all the way from -1 to +4. So that's where I'm going to choose to draw my coordinates. I then ask myself, are these open dots or are these closed dots? This one has the equal sign. This one has the equal sign. So they're both actually filled in. The next question is, do I color it in the middle, or is this heading off into infinity in both directions, opposite of each other? Well, if I cover up half of this inequality with my finger, I get X, and again, I'm going to read like backwards. I'm going to start at the right side and read backwards, asking myself, is the alligator choosing the X? Is it greater than the X? Or is the alligator choosing the value? Is it less than? If I read backwards, I say X is being eaten instead of the -1. Therefore, X is greater than or equal to -1. X is greater than or equal to -1, which means I have to head up in the more positive direction for that -1 value. But I could also do the same thing and cover up the left part of the equation. X is less than or equal to +4. Less than means going down. So, in this case, they would be connecting in the middle. Now that's not always going to happen, but for this one, it does. It connects in the middle. The only other issue that you might have encountered would have been with part G. We've actually done an equation that's similar to G before, but we just haven't done it with an inequality attached. What we would need to do to get the X by itself would be to square root both sides. But whenever we square root both sides of an equation or an inequality, we have to do a plus or minus. Now this gets a little bit tricky because actually when you multiply by a negative, you have to flip the sign. And so technically, like I said, this might have given you a bit of an issue. It should actually end up being X is greater than or equal to +2, or X is less than or equal to -2. Now, like I said, I'm going to go into this later. I'll explain more further once we get into this a little bit more. But whenever we have a negative sign, when we've multiplied it by a negative, we actually have to flip the inequality. So instead of facing this direction, all of a sudden this one faces that direction, only with the negative sign though. Okay, so let's go ahead and plot this one out. Again, we start at our 0, up 1, 2, down -1, -2. I know that I need to have at least a coordinate at the -2 and at the +2. I don't know if it's filled in or empty quite yet, but let's take a look at our symbols. I see the half of the equal sign on both of them, so I'm going to go ahead and fill in those dots. The next question is, what direction are they heading? Are they heading towards each other or far away from each other? I see this first one. I have X is greater than, X is being chosen or equal to the 2. So X is greater than the +2, which means it should be heading up in that direction, starting at this +2 and heading up that way. And let me just double check that that's accurate. X is less than or equal to -2. Less than would be heading down in the negative direction. So yeah, this one is heading off to infinity opposite of each other in both directions. After you finish that problem, you started working on creating the inequality that went along with the graph that you were given. And I'll go ahead and differentiate this little part. Well, what do we do here? We have to figure out what coordinate, what is the locator point of this inequality. In this case, it's the number 1. We know that there's always going to be an x or a value involved. And if you weren't able to see this quite as clearly, this is what the inequality looks like. So the first question is the dot open or closed? It's a closed dot, so we know that there has to be half of the equal sign involved. That's my half of the equal sign, it's not a negative sign. My next question is x greater than or is x less than? Is the arrow traveling upward or is the arrow traveling downward and more towards the negative values? In this case, it's heading upward, so we have a greater than or equal to symbol. Next up, we still have the value of 1, so again we start with the 1 and the x. Then we ask, is it open or closed? In this case, it's open, which means we're not going to put half of the equal sign. In this case also, it is traveling downward, which means x is not greater than, but rather x is less than the positive 1. Next up, we have a closed dot at the positive 3, traveling in a downward trajectory, which means that we have the half of the equal sign involved, because again, it's a closed, filled-in dot, and it's less than because it's traveling downward. And last but not least, for part D, again, we have another nice, oh, wait, I did not see that one. That one is empty on the left. Sweet. So this one's so cool because you're highlighting everything in between it, which means we have to say, okay, it's traveling from -4 up to +2. And x is in the middle. X is less than, or equal to, it's a filled-in dot. So less than or equal to +2. But x is greater than the -4. How do we do a greater than when the x is on the right? We just think, okay, x is bigger. The alligator is choosing the x instead of the -4. It's choosing to take whatever x is. So therefore, we draw our alligator so that it is eating the x instead of choosing to eat the -4 as the bigger of the two values. You will notice that this inequality is different than that inequality. Without the equal sign, with the equal sign.